So yesterday we kind of talk about the big picture. Again, something like what is physics and why do we care about physics and how to study. And the important thing is if you follow my requirement for everything, and hopefully if you can get a study group, uh, to work together. I think that's the best. Okay, for this and for the homework, I would suggest you guys to start early. As far as you learn it, you go to the homework to find the after each lecture. Go to your homework, find the corresponding problem you feel like you can solve. And then this way, if you have questions early, you can ask me, and then we can discuss this. Don't wait until the last night before the due date to do it. So that's why I don't want to put our deadline to be like, for example, 6 o'clock in the morning, because if I do that, some of you may do your homework all the way to like 5 a.m. or something, So I put it right before midnight, like 11:59. So this way, at least you can get a good sleep. But again, don't do that. It's not a good way to do it. Try to do it as early as possible. Try to talk to people. Try to ask me questions. Talk to your friends or like classmates. So let's start with talking about chapter 1. The specific name of chapter 1 I forgot, but basically we're gonna do like kind of introduction. I can write better on the real chalkboard, but this is not very okay. So basically, the idea of chapter 1 is kind of we're gonna kind of talk about something basic. Actually, in some sense, we were already doing chapter 1. When we give this big picture to you guys and then explain what is physics, why do we do physics, and how do we do physics. It's kind of like the picture we have. So maybe let me set up the virtual background. Okay, so and so again, this is something to make sure everybody is kind of in the same page and we all know the basics. And then we go from there. When we in chapter 2, we'll start really the subject we want to talk about. So remember we said in the big picture, right? So the most fundamental branch in physics is called mechanics. Now, so why do we start from there? Because it's basic and it's simple. So now, as you can see here, right, we have this very complicated, tons of stuff, right, in our universe, right, in the world, in the nature around us. So physics is something to study the nature, but what kind of nature, what part of nature do we start first, right? So, and because physics is a fundamental branch in nature, in science. So we will always start from something basic, the most fundamental and most basic things. And it turns out that is mechanics. So what does mechanics mean? Okay, so basically, this word here means like study. Mechanics is something about motion. So in mechanics, we care about motion. Okay. So most time in this semester, this is going to be our central topics. Okay? We will study motions. Okay, and it's kind of like motion we talk about today, like the free fall motion or like throwing something. All kinds of motions. So we'll start from there. Okay. Now to do that, we will start from introducing something basic. So the first thing we want to talk about is called fundamental physical quantities. By the way, a lot of stuff we talk about in chapter 1, there's something probably you already know or you know a little bit. Again, that's because this is an introduction. We're just bring up everybody to the same page. And then, so if you feel like this chapter is easy or something, and that's it because it should be, And then starting from the next chapter, we'll get to some like real stuff. Okay, so So what are the fundamental physical quantities? Okay, suppose you have a motion, right? Like this, like a ball or anything, right? Going in the trajectory. The question is, what kind of quantity? What are the fundamental quantities you can use? Fundamental physical quantity you can use to describe this motion, right? So that's what we mean by fundamental quantities. Okay, or you can think about another way. Let's say you want to have a date with a friend. I mean, with somebody, or have appointment with a friend, or with anybody. You know, the question is, what is the specific things you need to specify? Okay, say you want to have appointment. What kind of thing you need to specify to have the appointment?
Time.
How do we specify appointment? Let's say you want to you write a you in the bar, you see somebody you really like, you want to like have a date with that person. You write something on a small, I guess nobody's doing it anymore, right? I mean, you write a small note and give it to that person. What do we need to specify on that small note in order to have a successful date?
Like a time and a location.
Exactly, right? You have to have a time, right? Otherwise, who knows what's nobody knows when to meet, right? And same thing, location. Without location, again, it's impossible, right? So time and location certainly are those fundamental thing you have to specify, right? Well, there's a third thing, which is a kind of a obvious in the case of a making an appointment, which is basically who is gonna be there, right? Right, that makes sense? Well, I mean, by giving that person this note, that person knows like you're gonna be there, right? So again, so these are kind of the three fundamental things we have. It's actually the same thing we want to describe for describe motion. We have time, a location. So actually, in some sense, in physics we normally call it space. Now, in this specific context, we call it length. Okay, but that length gives you something about space, information about space. Okay, the last one is who is going to be there. So in physics, we call it mass. Okay, so these are the three fundamental quantities in physics or in mechanics specifically. And actually, if you think about it, this is universally useful because you hear about news, right? When the news report you an event, okay, they need to specify these three things as well. They need to specify when it happens, where it happened, and then what has happened. Basically, like who is involved in this thing, or like for example, a car accident, or a protest, or whatever, you know. So so these are the three quantities, and then they're fundamental because you have to have them no matter what, right? So let's talk about them one by one a little bit. Okay, so let's start from length. Okay. Now, when we talk about physical quantity, what do we need to know here? Okay, because again, remember, physics is a experimental science, right? We experiments where everything come from. So we need to know basically how to measure length. Okay, I guess you guys probably already know what kind of instrument do we use to measure length? Anybody?
Ruler, measure.
Right, exactly. So we use ruler and like a meter stick, tape measure or something, right? So we use this thing to measure it. Okay, it's very important to know how to measure this quantity. Okay, and then another thing related to that is what unit do we have for this unit for this quantity? Because when you measure them, right, certainly you get a number and a unit, right? And then so the units we have, anybody can give me any units?
Meter.
Right, definitely. Meter is 1 unit. Well, along this line, we have like a centimeter or a millimeter. And then on the other side, we have a kilometer. Actually, there's another kind of units we have like we use a lot in America. Like for example, we have a foot and inch and like yard, mile, right? So all these units are something we've seen before, and they are all good in terms of measuring the length. Now here comes a very important difference. Okay, so we have these two kinds of units. So in this class, we're going to use the first kind. Okay, we use this side of a unit instead of the second side. Okay, so and then specifically the meter here is our main unit. Okay, these set of units we use are called SI units. Okay, uh, SI unit. Okay, SI here stand for System International. So these are basically the units have been used across the whole world. Okay, uh, actually, I think U.S. might be the only country that's still using the second set of units. Most other countries use this first set, so that's why it's called System International. And actually, when you do physics or chemistry, even biology, I think they all use this international system unit. So they all use like meter, centimeter, millimeter, etc. So it's important, kind of useful for you to know these units. Okay, and this is going to be unit system we use in this class. Okay, now the second kind of unit system is called. It's actually belongs to like a you can call it British unit system. Okay. Now because they came from UK essentially. And then for example, this foot, right? Why is it called a foot? Okay. Well, essentially because at the very beginning, this unit was defined using a king's foot. Okay. You take actually the king's foot is 1 foot. Okay. And then you can use that king's foot to measure other units. Okay. Well, as you see here, right? It's not a very good way to define a unit because the king's foot obviously can change as the king grow older, right? The length of the foot may change a little bit. And it's all possible the king could lose his foot, right? And then what's going to happen, right? So it's not a good way to define units. So later on, people use more objective ways to define. For example, for the meter here, right? They used to have like a bar, make a metal bar, and is exactly this length, and then they keep it in a constant pressure, constant temperature environment so that the bar will stay with the same length. Well, certainly that's way better than using king's foot to be a unit. But even that may change, right? So even better, people now use a speed of light to define meter. A meter would be defined as the how much light travels in a very small time interval. Okay. Again, those things are some we don't really need to know that much, but it's good to just hear about it, you know. But anyway, we'll stay with this SI unit. Sometimes this is also called a metric system. The reason for that is all these units here they're different by integer numbers of 10 times. For example, 1 meter equals to 100 centimeter, and then equals to 1,000 millimeter, and 1 kilometer equals to 1,000 meter. So see, all these difference here are by order of 10, 100 or 1,000 or whatever, right? Well, if you go to the British unit system, it's not, right? Like 1 foot is like 12 inch or something. So it's actually easier to do unit conversion and everything in this unit system. Okay. So let's see, that's what I want to talk about. Okay, by the way, there's these all of these things here, centi, milli, and kilo. They're like the prefix. They're kind of standard prefixes, okay? And we use them to express to add to the main unit here to give us other units. Now let me pull out the let's see, college physics. This is the book. Okay, this is a little bit different book, but I think that's good. Okay, so in the book you'll find the actually maybe let me try to pull out the 11th edition. So no, not this. I need to find out the textbooks. Where textbooks? Wait, are they here? Okay, here. Okay, let me find the. So the textbook for this book right here is 11th edition of the. I think that's it. No, that's it. This one? No, that's 9th edition. Hold on a second. I want to show you the table in the textbook. No, this is not. Where is it? Called 10th edition. Maybe I'll just use the 10th edition because I don't think I have the 11th edition here. But they're almost the same. So, okay, hold on. Let me. Okay, so anyway, you find out in your book, there's like in chapter 1, there's a table here. See all of these. Yeah, see this table right here. Prefixes. So see the centi, we mentioned the centimeter, centi, right? This is like 10 to the minus 2, and milli is 10 to the minus 3, and then kilo is 10 to the third. So there's all kinds of other prefixes you can use. And then it's all listed here. Now in some of the homework problems, you may need to know the meaning of those prefixes in order to do the homework, okay? Again, if you have any questions, stop me, feel free to stop me or send me a text. Send me a message and I can explain that. Okay, so we have this unit here. Okay, for space. Now let's look at the next one. Okay, which is time. Okay. And again, we need to know how to measure it. Okay, well, in this case, again, pretty trivial, right? We can use a clock or a watch to measure time. And then we need to know the units. And there's this time the units almost everybody use the same kind of unit system, right? So the main unit we have here is a second, or in short S. And then we have something related to that, which is a minutes, hour, and the day, months, and year. Okay. Now, these units are not as easy as metric system, like in the sense that it's not like out of power of 10. You like 1 minute is like 60 seconds, 1 hour is 60 minutes, right? So this is coming from like some historical reasons. This is a base of 60 conversion been used by a long time ago in like great ancient Egypt and other places. So people just kind of got used to it, and then we all use the same units here, all the way to here. Okay, so well, time is actually a little bit different from space, right? For example, from length or space. For example, when you talk about length or space, right, you can easily go back and forth. You can go from one place to another place and then coming back. Well, for time, you cannot do that. We all living in a specific clock, right? Right now it's like 11:13 in the morning, and then there's no way you can go to yesterday, right? Not to mention come back, and there's no way to go to tomorrow at this moment. So and we have to stay in the same kind of clock. So that makes time seems like a little bit more mysterious than space. And then a lot of people talk about like time travel using a time machine or something, but unfortunately, all of these are impossible. And the reason is very simple. For example, you cannot go back to the past. Why? Because the past does not exist. Okay, the past is not present. Okay, so the past is gone. That's why it's called past. Okay. I mean, I guess we can talk a whole lot more about this, but that's probably sufficient. So let me finish the last one here. The third one we have is called mass. Okay. Now we use like a, well, it's very easy to confuse mass with weight. Okay. For example, when we measure something in the scale, most time we get weight, not mass. Okay, so strictly speaking, we use balance to measure mass, and then the SI unit for mass is called a kilogram or kg. Okay, now you guys know the unit in the British system.
Pounds.
Okay, actually these are not. Okay, you may say pound or ounce, but they are actually not the unit for mass. They're unit for weight. Okay, it's a unit for weight. There is a difference between or force. Okay, there's a difference between mass and force. Okay, we'll talk about that difference. Okay, there is a British unit for mass itself, but nobody uses it, so I don't really remember the name of it. So we don't need to worry about it. But we're going to use the SI units, which is kilogram. Okay. I think that's all I want to talk about today, and we're running out of time. So let's start right here. You can go ahead and do your homework. Okay, for week one. We only covered a small part of the chapter, but a lot of problems you may already know how to solve. And then just if you feel comfortable, you can go ahead and do it. Okay. Okay, that's it for today. I'll stop record the video, and then you guys can. Okay. So what we learned yesterday was, I mean, in chapter one, basically we're starting from mechanics. So and we start from this three fundamental physical quantities: time, length, and mass. Okay, so these are the three quantities you need in order to specify a event, or like appointment or a date or whatever, you know. And that's the same three quantities necessary in order to describe a motion. Okay, and it's not all we need, but it's the fundamental quantities we need. Okay, so we went through all the three of them. So today let's continue our discussion. Okay, I think this, okay, good. So based on the fundamental quantities, what we can do is we can talk about something called derived quantity. Let me see, put it here. Okay. So the idea of this is actually, let me give some example of the derived quantity. For example, right, consider a quantity called area. Okay. Well, this is actually it's actually a geometrical quantity. You guys probably already know from your geometry class, right? But let's think about what is the let's say, for example, if you consider a rectangle like this. The area of the rectangle, if you know this is the length and this is the width, right? What is the area? How do you calculate the area given the length and width?
Length times width.
Exactly. So it's going to be L times W, right? Now, we call this area a derived quantity because see, each one of these lengths or widths are essentially one of our fundamental quantities, right? It is just the lengths we're talking about here. So in this case, by multiply the two lengths together, we got the area, okay? So area is length times length, basically. And and the advantage of looking at this way is we do not need to define a new unit for area because this is a length, another length, right? For length, we know the unit, excuse me, as we discussed yesterday, is just meter. So we have meter times meter in this case, which is basically just the meter square, right? So by understanding that area is defined as length times length, we could multiply their units together directly and get the unit for area. We do not need to define the unit for area independently. Okay, it's not totally independent. It depends on the formula here. So that's one example. Okay, let's look at another example. Okay, maybe I should. Let's say maybe volume. Okay. Well, for example, if you have a rectangle box, right, like this. Now, in this case, you have length, width, and height, right? Now, how do we calculate the volume of this box?
Length times width times height.
Exactly. Length, width, height, okay, like this, okay? So that's that's the volume. And again, you can view volume as a derived quantity because this is essentially just a three lengths. So you have meter times meter times meter. So the unit is simply meter cube. Okay. So now let's look at another one. Okay. Density. Well, this quantity is kind of new for some of you, and we will learn it if we have time in the chapter 9 when we talk about fluid. But for now, you could just understand it like its density is like a kind of how dense the material is. So it's basically like a mass per unit volume. So we would define density as mass divided by volume. Okay. Now again, this will be like a derived quantity because mass is one of our fundamental quantity, and volume is a derived quantity we talk about here. So based on this definition here, the unit for density is again not totally independent. It'd be just like the unit for mass divided by unit for volume. So you have kilogram divided by meter cube. Okay. And finally, let's look at the other one. Okay. Let's call it a speed. Okay. And we'll talk about this quantity in depth when we talk about chapter 2. Okay. But again, for now, speed basically just tells you how fast this object moves, right? So it'd be like the way to measure it would be like taking distance divided by time. And this is again a derived quantity because this distance is just nothing but our length, and length and time are both our fundamental quantities. So we can derive the unit again for speed. What will be the unit for speed? If you have the unit for length as meter and the unit for time as second.
Meters per second.
Exactly. Lauren, I feel like you're answering every question. I really appreciate that. But I kind of hope like the other people can kind of answer some of these as well, you know. Anyway, so that'd be meter divided by a second, right? So meter per second. So that's the SI unit for speed. Again, it's not an independent unit, right? You don't have to define a new unit for this quantity. Based on what we have for the unit for the fundamental quantities, we can get the unit here. So these are just some examples of the derived quantities. In this semester, in some sense, what we're going to do is we're going to learn one after another quantities. And pretty much all of them are derived quantities of these three fundamental quantities. And and for each one of them, right, we'll spend some time and we'll learn the physical meaning and how to use it, how to put in the word problem, et cetera, et cetera. So that's about derived quantity. Okay. Then from there, we can talk about next topic, which is called dimensional analysis. Okay. Now, how many of you know what is the dimensional analysis? Okay. No, nobody. Okay. Uh, this is actually this word here. It may be a little bit confusing. It looks mysterious, but actually, the meaning of this is just nothing but unit. So, dimension analysis really means unit analysis. Okay. So, or you can call it like a unit calculation. So basically, what we're talking about here is you have this, for example, right? Like here, when we try to get the unit for area, how do we do it? We know area equals length times width, right? So, and we know the unit for each one of these. Then we simply multiply the two units together to get the unit area. So that's essentially a unit analysis or dimension analysis, okay? Essentially, we're calculating things with unit, okay? Well, similarly here and here and here, these are all, you can consider all of these cases are dimensional analysis. And this is the specialty of physics. Well, when you're doing math, right, you're doing calculations, but most of the time you're using pure numbers and there's no units for them. But in physics, a lot of times, many cases, you're doing calculation with physical quantities. And those quantities do have units. And then those units will give you, and so you can do calculations not only with numbers, but with units, okay? So, so why do we care about that? Okay. Now, first of all, this can help us to figure out what's the unit of a new quantity, right? Get a unit of a new quantity. Basically, if we know the mathematical definition, we can actually calculate the units of this the thing by doing this dimension analysis. Okay. Now, second of all, it actually helps you to check your answer. Okay. And if you actually keep the units of everything in your calculation, it can help you to see whether your answer is right or wrong. For example, let's say suppose you're supposed to calculate speed. Okay. Let's say you keep the units of everything, and then in the end you get like meter times second, right, as a unit of this thing. Now you immediately know that this is not going to be right because the unit for speed is meter per second. Okay? So meter times second is something else. So by doing that, it's actually tells you that this is wrong. So from this point of view, if you keep the units of your numbers, when you're doing calculation, it can tell you whether it's right or wrong immediately. Well, it certainly is. It doesn't mean that is necessarily right, even if you get meter per second, right? Because your number may still be wrong, but at least it is correct in terms of the unit point of view, from the unit point of view. So it's still going to be okay. Now, actually, this one can also check your equation, help you check the equation. Let's say, suppose you you want to solve a problem and then you remember some formula here and you try to use the formula. Well, whether is that a correct formula or wrong? Okay, there's a way to tell. For example, you can write like let's say if you have a meter on one side of the equation, okay, like a length, and then on the other side, let's say you have a speed times time, and you know this is correct because speed times time, right? This is meter per second. This is a second. Together you got meter. That agrees with what you have on the left. Okay. So on the other hand, if you have I think we should like maybe zoom in a little bit. Okay, this way I'm going to use everything. Okay. Yeah, I'm not using the full page. So on the other hand, if you use like, let's say length, and then you remember the formula or something like length equal to speed divided by time, okay? Well, that's not going to be right because this speed is meter per second, right? And time is another second. So you have meter per second square. Where on the left, you have meter. Certainly, they cannot equal each other because they're not, it's not same unit on both sides. So this is definitely wrong, okay? So again, this can help you to check whether the equation you got is wrong or right, okay? Now, as I said, you don't need to worry about this because I'm going to give you the equations in the test. But still, this is something that can be useful, handy for you, you know, when you're doing a specific problem or something. And actually, another idea is actually the unit can help you to figure out the equation, okay? Create equation. I'm going to just give you a very simple example, very interesting example. Let's say, suppose you want to calculate the area of the of a circle, okay? Now you only know the radius, okay, of it, okay? And let's say, suppose you don't remember the formula. You don't remember how to calculate the area of the circle given the radius, okay? How do you do? Well, how do we figure it out? Now, there's a simple way to do it is using this dimension analysis thing, okay? Now, how do we do that? Now, again, remember area has a unit of meter square, right? So that means if you want to get area out of a length, so you want to go from length to area. And this is meter square, right? And this is a meter. How do you get meter square from meter? Well, obviously, you need to multiply two lengths together, right? So by multiplying the two lengths together, you got meter square. So what kind of length do you have? In this case, there's only one length you have, which is nothing but the radius, right? This is the only length you have. So that suggests that you have, if you want to get the area, you have to multiply multiply the radius by itself. So you have r squared. So you would guess the area of a circle to be something like r squared, okay? Because if you get r squared, the unit is correct. Okay? Meter square is meter square, so that's correct, okay? Well, as we know, it is not 100% the right formula because the right formula is actually pi r squared, okay? Where pi here is the number. You cannot get the number right by doing this unit analysis, but at least you got this r squared part right, okay? So at least it give you a bulk part right, you know, a good estimate of what it should be. So that's how you could guess maybe let's don't call this a create equation. Let's call this a guess a equation, okay? Let me try to use the eraser here. For some reason, the eraser was not working well. Okay, I guess I'll just cross it. Okay. So guess the equation, okay? So that's how you guess the equation based on this, okay? Any questions? Okay, we're good. Okay. Okay. So again, this part here is in some sense it's just introduction. We're not going to do a whole lot of problems on dimension analysis, but I think it's something useful to know this, and then we'll use it. And mostly the first usage of it, like getting units of new quantity. We're going to use that a lot. So that's good to know. Okay. Now, next topic is probably the more relevant in terms of doing calculations. So let's talk about unit conversion. Okay. Okay. So, and this is something really something you really need to know. Like, for example, if you have something like in let's say 30 meters, right? Now you want to convert it to a kilometer, right? Question how many kilometers you have, right? Something like this. Now I'm pretty sure you guys already know how to do it, right? If you know how to do it, give me a thumb up. Unit conversion. Okay, I got a few sum up. Okay. 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 Few you guys give me sum up. Now, okay. Anyway, let me go through this. Okay, so how do we do unit conversion? There's all kinds of ways to do it, but the important thing is to know the relations between the two units here. Okay, you have to know the relations. Otherwise, there's no way you can do it. Okay, as we know, right, 1 kilometer equals to 1,000 meter, right? So that's the relation between this unit and this unit. Okay, now we need to know something like this in order to do this unit conversion. There's a different way to do that. Let's do it. So the idea here is you want to multiply this by 1. Okay, I'm doing it really slow here. So you multiply this by 1, certainly that's still equal to this, right? Now the next the key here is to write this 1 here using this relation. Okay, you can write this 1 in terms of 1 kilometer divided by 1,000 meter, right? Because that they're equal, so this is just 1, right? So this is equal to this. The idea is you want to write the units that you want to convert from in the denominator and the unit that you want to convert to in the numerator. Okay, this way this meter here and this meter here can be canceled out. Okay, so what's left is this new unit. Okay, and then what is left here is just some numerical calculation. You can use the calculate by hand or use a calculator. 30 divided by 1,000 is 0.03. Okay, kilometer. So that's the answer for this conversion. Okay. So again, the key here is to multiply this a fraction that equal to 1 that using this the relation between the two units. Okay. Now some you may learn this in your chemistry class. Like I know they use a little bit different, but essentially the same thing. Let me show you. Okay. I want to put this thing. Okay. Okay. Good. So let's say some of you may learn like this. Okay. You in the chemistry class you may draw like this. You know, put a 30 here, meter. Put 1 kilogram here. Put 1,000 meter here, right? And then is that the way you guys do it? Some of you guys seen this before? Okay. And then from there you get the same thing. You do division of this two. You get like a 0.03 kilometer. Okay. Well, I would say these are essentially the same thing. It's just this is just a little bit a different way to write the fractions you have. On that the same. Okay. So let's do one exercise. Okay, together. Okay. Now again, remember, by doing this exercise, you get a little bit bonus point for this course. Now, it's not a whole lot of bonus point. Pretty much we're gonna do 1 or 2 of these kind of exercise in each chapter. So together, in the end of the semester, you get, if you do every one of them, you get about like a 5%, 5 to 6% of the whole credits. It's not too much, but I think it's kind of like icing on the cake, you know, kind of make the cake enjoyable, you know. And also, again, my point is I want to encourage you guys to show up in this real-time lecture instead of just going to the video. So so I can easily know who is here, who is not here by looking at your attendance sheet. So let's do this exercise together, okay? So say you drove to Canada, right? And then on the highway, you see a speed limit sign, okay? But the sign here is saying 100 kilometer per hour. Well, this is certainly not something you kind of have a sense, right? Because we're used to mile per hour, right? So we want to convert this to mile per hour, okay? Again, you need to know the relation between the kilometer and mile. So let's say 1 mile is about 1.6 kilometer, okay? So let's try to convert this speed limit to this new unit, okay? So let's do it together. I'll give you guys a couple minutes, okay? You can use this way of doing it, or if you have your own way, you are familiar with this, you can do it your own way, you know, either way, okay? Go ahead. and after you're done, you can send me a private message so I know you're done, you know, and then I can check whether it's right or wrong. Okay.
Can you repeat the question? Oh, the exercise? Is that what we're
Convert
doing?
convert this to a new unit, mile per hour. So you have 100 kilometer per hour. Write it in terms of, maybe let me put it like equal sign here. So set them equal whatever mile per hour. Okay. Convert this to mile per hour.
How do we send you a private message?
You can go from let's say, like click on here. I mean, click on chat. Okay, chat, and then you can send a message from there. Okay. Okay, and after you give that to me, I can tell you whether it's right or wrong. Okay. Okay, I think most people have sent me the answers. Okay, let's see. 1, 2, 3, 4, 5, 6. We got 6 people sending me. So there's still like one person is working on it. Okay. Okay, I think that's probably most people. So that's a good. Okay, again, let me emphasize. Okay, when you're doing this exercise, don't feel like a lot of pressure. Don't feel like you have to get it right in a couple minutes or something. This is normally the exercise you're doing here is what you're doing right after you hear listening to my lecture. You know, so if you're watching at home, you know, I mean, like, and not at home. Sorry, if you're watching this lecture at different like by the video, you cannot get this bonus point, but you should still practice, you know, and so but the point is you need to pause and then use a couple minutes to practice, you know, and if you don't get it right, that's totally fine, because this is the first time you practice on something you just learned. So the idea is not to get it right. The idea is let you give a try to what you just learned, you know, so that you can practice a little bit, and then hopefully this kind of build up a bridge between our lecture and then the homework problem you do. Okay. Okay, so let me talk about this together. Okay, this is not really complicated, right? So suppose you say you have 100. Let's see. Okay, I guess I need to kind of go back to the writing mode. Okay, so so the hour part is the same. The only thing when you change is the kilometer to mile. So if you write like 100 kilometer per hour, right? Then using this idea, using this trick of writing a fraction. So you can write this like this, okay? Put a mile on top. Sorry, yes, and then 1.6 kilometer at the bottom, okay? Now this kilometer and this kilometer kind of cancel out. So the unit left is mile per hour, which is what we wanted. So, and then So you have mile per hour. And then the numerical power here is 100 divided by 1.6. So if you do this, you get 62.5, okay, mile per hour, okay? So as you see here, right, when you see the number says 100, doesn't mean you should drive like 100 miles per hour, right? Because it's a different unit. You should still kind of, I mean, it's only 62.5 mile per hour, okay? So it's not really high speed limit, right? It's just like a reasonable speed limit, okay? Again, if you have any questions about the exercise, okay, either talk to me directly or send me a message, okay? This way I can address it, okay? This is good for everybody. Now we got a couple of this kind of exercise in our homework as well. So you'll be able to do it in our homework, okay?